Hello everyone, welcome to the channel Lead Life Code. Today we are in the third session of the data structure series and we will be discussing today around the linear dynamic data structures. So in the first session we had learned what are linear, nonlinear, dynamic, static data structures. So in linear dynamic data structures, the first one is the linked list. The second one is queue. Third one is a stack, and the fourth one is a map. So let us get started with linked list. So linked list is basically stored in the form of nodes. So how it looks pictorially is, let us say this is one node. In that node there would be a field called value and there would be a pointer. The pointer is basically the address destination of that particular node. So how does it work if there are multiple nodes inside a linked list? So it is something visually represented like this. So the pointer here points to the second node, the pointer here points to the third node, and so on and so forth. So there are actually four types of linked list that you would see. One is the singly linked list, one is the doubly linked list, then we have the singly circular, and then we have the doubly circular. Okay, so this one which I showed you first is the singly. This is the singly, how the structure of a singly linked list is visually represented. For a doubly one, as the name suggests, every node has two pointers, p1, p2, and the value resides here. So what happens here, it is kind of a bidirectional. So you can traverse from one node to another using the start and the end pointers that is available. So for node 1, this is the representation, node 2, node 3. Okay, so this becomes bidirectional here. So using the pointer of node 1's end, you can reach to the second node and vice versa. That is why it is called as doubly, where there are two pointers in it. And then there is something called singly circular. So here the nodes are singly, like value, pointer, value, pointer, value, pointer. But the last part, the main important part or difference between the singly and singly circular is this pointer is actually again linked to the first one. So node 1, node 2, node 3, and node 3 can again traverse to node 1 because of this property, but it is only unidirectional. This doesn't have two pointers here. And the doubly circular, as the name suggests, you would imagine it is p similar to the singly, but here the end pointer of the last node would be pointing to the first node's starting pointer. Okay, so these are the four types of linked list that you would find when you are learning or using data structure. Now let us go to the next uh, data structure, that is stack. So as the name suggests, stack, what do you mean by stack? Stack is something that you put pile on one after the other, right? So basically this is comes under the pattern of LIFO, last in first out. So imagine if you're putting a data object or an item first, second, third, fourth, fifth, while retrieval, you can only start from the first one. That is, the one you inserted the last can be read at the first. So this is very useful where ordering is important. Wherever you find a problem statement where you have ordering as a primary implementation need, I think stacks would be a great data structure to use. Okay. Now let us see the next one, that is queue. So as the name suggests, you would imagine queue is basically uh, it's kind of a pipe, you can imagine. So the data is not is open-ended. So there is, you input it from one end, you can output it from the other. So basically it comes under the feature of first FIFO, first in, first out. So here the important aspect is the arrangement part of it is important. So based on priority, you normally execute it. So if something is coming in first, it should be the first thing to be executed or processed. That is where queue can come in real life. You can imagine like your scheduling is a great uh, use case where you can use the ticketing systems that we have got, like getting into IRCTC or an airline site. So they would reserve your seats, right? For 6A, 6B, 6C are the seats that you would have in your airlines. So if you are taking it up, they would run a timer of 15 minutes and they will log that for 15 minutes. That is where this queue mechanism actually works, in that you are the first one to come in and you would be the first one to served or provided that access to those seats or anything else. So this is very important. There are various types of queues. One of them is a priority queue that you would really use it, especially when you're designing any notification kind of systems, where let us say you have got some messages which are segregated based on their priorities. Say a message from a very important person should be delivered first, a message from a very I would say a disaster message should be delivered first. So those kind of things you would use a priority queue. So based on priority, the notification order changes or the processing order changes, and that is something very useful in some of the mature notification systems. The last one for today we will learn about is maps. So map is basically a key value pair. So it stores data in the form of key and value. Key value. Okay. So one of the great examples of this key value pair map is Redis. Redis is a very important uh, system that stores uh, data in the form of key value pair, which is highly used. So yeah, I think in the real world, when you go into designing, these data structures would be coming into much handy when you plan what kind of data structure to use for what kind of problems. Hope these four introduction or a brief overview of these four gave you some refresher, some confidence on building a good robust system. Yeah, we'll go into depth in the future series into all these data structures. But for now, thank you very much for patiently listening to me, and please subscribe to this channel if you are finding it useful. Thank you very much.